I mean, there's, yeah, there's, okay. Continuing on, now that you're well fed with your pigs in a blanket.
This is delicious, by the way.
We are going to talk function notation. Now, this is one of those things, you might have seen it in Algebra 1, or you might not. I think you did, but occasionally it gets skipped. If I write that notation, do you know how to say that?
Function notation?
You know how, f of x. That's right, f of x. The function in terms of x, meaning that x is going to be the variable in this function. So I'm going to write something out like 3x squared minus 2x plus 1. And so in this case, this particular function,
Is that a second?
that's a square, 3x squared.
Why, is there a line under it?
That's my subtraction sign, sorry.
What's on top of the subtraction sign? Oh, never mind. I get it now.
There, does that help?
That makes a lot more sense.
Okay.
Okay.
So you say it as f of x. It simply means that, hey, if you see that notation, you know this is a function. This one passes the vertical line test. The x-coordinates don't repeat. If it's written with that notation, you know for sure that you have a function. Okay, what they're going to ask you to do, though, is they're going to say, find f of 2. Now, what does that mean they want you to do if they want you to find f of 2? Yeah. They literally, if you're going to find f of 2, they want you to put 2 in for every x you see in the whole equation. So you're going to have 3 times 2 squared minus 2 times 2 plus 1. You're putting 2 in for every single x up there. And then you need to simplify it and see what you get. So, okay, order of operations. What do I do first here? Exponents. That would be 4 times 3, which would give me 12, minus 4 plus 1. And then, of course, we add and subtract last, which is going to give me a, what number? Thank you, 9. Don't all leap on that difficult arithmetic at once there. Amen. Okay. What you have to understand, what you just did there, you just put 2 in for x. Okay, so if you were writing coordinates, you put 2 in for x. The answer you get out of it when you find the value of a function is nothing more than your y-coordinate. You just found out that the point 2, 9 is on the graph of this function. Okay. So when you see f of x is the same thing as we usually write equations as y equals. F of x is the same thing as y equals. It's just indicating that, hey, dude, this is a function. The only difference.
Wow. Did you just get a random 2? Did you pick the random 2?
Yeah, I did. I just picked 2. Yeah. So let me have you try one more, make sure we got this. Well, it won't draw that line for sure. That's supposed to be a fraction. And now I'm going to do something incredibly evil.
What? Fraction.
I'm going to make you put a fraction in the fraction.
Oh, my calculator's so smart. I can type that in there.
You could. So where should I put 1/2? Where x is. Every x. 3 times half minus 1. Down the bottom I also put a half in and I have to square it. But we're going to simplify this with our brains.
25 over my brain shot.
Okay, that's not an answer is not ever a you can never have decimals in a fraction as an answer ever. Simplify it. You don't have a fraction over a fraction either.
Squared is 1/4.
So when you take 3 times a half, what do you get?
3 over 2.
Thank you. You get 3 over 2. And then I'm looking at this going, ooh, I'm going to have to subtract 1. I'm going to need a common denominator. How do I change 1 into something over 2? It is 2 over 2. So I have the incredibly difficult 1/2. when I subtract those. 3 halves minus 2 halves. Okay. Now, how do you square 1 half? 1 half times a half. Or square the top, square the bottom. That would be a fourth. Square 1, square 2. You don't know how I got 1 half? 3 halves minus 2 halves. Subtract fractions, you subtract the numerators, leave the denominator the same. Now, last but not least, how do you divide fractions? Nope. Flip it. Flip. Reciprocal of which one? Okay. Vote. Do I flip? I have to do this, multiply by the reciprocal. Reciprocal of the top, reciprocal of the bottom. The bottom. Oh, yeah. So you take 1 half times 4 over 1. What do you get?
4 over 2.
You get 2. So tell me, what coordinate did you just get out of that little operation? When x is a half,
And y is 2.
y comes out to be 2. You found a coordinate.
That was taken, right?
Yes, that was taken. Okay, that's the first 2/3 of the book problems. Now I'm switching to the worksheet I gave you. That I will come back and do a little bit more that's in the book. Okay, this is a biggie. This will play with your brain until you get the hang of it. Okay, y'all just told me the domain was, why did I just see that throw? Go pick it up and don't ever throw it again, or you'll spend time with me. I'm going back to here. Okay, domain and range. Domain was the set of which? The x or the y? Okay. Domain is the x-coordinates. Range is the y-coordinates. Okay, now I'm going to get tricky on you. I'm going to ask you to list for me the domain and range, and first of all, I'm going to give you a graph and have you tell me the domain and the range. So, we're just doing a rough little sketch here. All right, there's a graph. The domain is the set of all x-coordinates that are used to create that graph. So I'm asking you what x-coordinates are used to create that graph.
-4.
Okay, -4 is?
-2.
No,
+2.
Positive. That's the only x-coordinate?
No.
everything in between, right?
Yeah, isn't this graph solid between -4 and 2? So aren't I using, for this x-coordinate right here, I'm there, it's right there. As long as this is solid, you're using every x-coordinate from one spot to the other. So it's not, I want to know exactly where do those fall.
You write it as an equality.
I want you to write it as an inequality, yes. So you're saying my x-coordinates fall between -4 and 2. How do we write that? We've just been doing it for a couple days.
-4 is less than x, which is less than 2.
Yeah, the same notation you already know. X is between -4 and 2. And yes, they would be less than or equal to because they are close. So it's that same notation you've already learned. Alright, range. Okay, now, range, notice, when you did domain, you were looking left to right on the x-axis. What was the leftmost point? What was the rightmost point? So when you're doing range, what are you going to do?
Up to down, down to up.
Yes, you actually want to go down to up, or you want me to go low to high? Maybe low to high makes
Up sounds a lot easier. Yeah, but you can't go up, down, stand up.
So on this graph, if you want to do the range, what's the lowest the y-coordinates go?
-3.
-3 is as low as they go. Well, how high do they go?
Zero.
They go to a y coordinate of 0. So therefore you would write this one, if they're going from -3 to 0, you put y in the middle, and do I put equals on it?
Only on the three.
Yes.
-3, it's equaling -3. Is it not equaling 0 up here when it's sitting on the axis?
No, it's just a regular sign.
But it's filled in, so it means it equals 0.
So it's equal to, they're all equal to.
They're all equal to. The only time they won't be is if they have an open circle on them.
Wait, they're all equal to?
So the,
As long as they're solid dots.
Wait, so what's equal to
Oh,
now?
whoops, I thought I wrote it.
Yeah.
I intended to write it. Okay.
Now you got it.
So, let me give you one with a little different view. Suppose
Hang on, baby. I'm not gonna dig in.
actually, I want to make that open. Are you leaving? Yep. You can let me know if you have questions later. All right, dude. I want domain and range on this one. Domain is left to right. I said dude. So what's the farthest left it goes? Okay, so we're going -1. How far to the right does it go?
On to go, infinity and beyond.
It's going on to the right forever, isn't it?
Yeah.
Okay, are there any breaks in it anywhere along the way? No, so as long as it's solid, it's using every x-coordinate from -1 on out to the right. So how do we write that in symbols, -1 and bigger?
You do that.
Yeah.
Sideways.
I would rather you would put your x is what? It's greater than -1. Should I have an equal sign? No, because I left it an open circle. Oh, you actually back it off. Okay, I'll have to throw the trash. Alrighty, range then. Range, you're thinking low to high. So how low does it go? The lowest it is, it's supposed to be at -3 here, yes. And how high is it going? It's going up forever. There's no breaks or gaps in it. So it means my y's are going to be, they're greater than -3 because the y's are going upward forever. And you've stated your domain and your range.
No.
Yes? No? Got it?
I think no one likes you, because no one's in the front row. You want me to come visit you? Where'd Taylor go?
Actually, I probably should have stopped it. Okay, so we're ready to talk serious domain and range. This is where it gets tricky. I'm going to give you the equation of something. You don't have to graph it. You could graph it, but actually you don't know the graph of this yet. We will learn this graph by the end of this chapter. I want you to find me the domain and range of this function without graphing it.
The absolute value of x.
Okay, so when you're doing domain, you're thinking, what x values could I put inside an absolute value? And actually it's easier to think, are there any x values you can't put in there? Is there any number you cannot put inside an absolute value?
Zero.
What's the absolute value of 0?
Zero.
0, so you can put it in there.
-0.
Probably a decimal.
Can you have a decimal in an absolute value?
Fraction.
Can you have 2/3 in there? You can put anything in an absolute value. So therefore, what's it mean the domain is?
Infinitely many.
The domain is all real numbers. And you get to cheat and just write the all real symbol. Now, range is where you'll have the issues. Range is what my y coordinates are going to come out to be. So you have to think, if I put numbers in there and I take the absolute value, what kind of numbers will I always get after I do an absolute value? Won't they always be positive numbers?
Yep.
So therefore, I'm always going to get y coordinates that are positive. So how do I write in symbols y is what if I want it to always be the numbers?
Is greater than or equal to 0?
you all admire that, she says greater than or equal to 0.
Yep, sounds great.
I would have guessed the point finger, so I guessed it.
Could you put y is greater than 0, or negative 1?
No, because it would,
Not equal to though.
yeah, but there could be a negative half and a negative fourth and all those
Oh,
other numbers in
brainer.
there, so no, you can't put negative 1.
15
It's
minutes.
0 and up, thank you. Okay, fine.